Hello guys, welcome to IB360. In this video we are going to study impulse and force time graphs. So in order to study or understand this lecture, you must see our previous video about impulse and momentum. If you see that videos, the concepts in this lecture will be clear to you. Okay, so let's just proceed over here. So impulse and force time graphs. So from the previous videos we have derived that impulse is actually what? Force into time, right? So impulse is actually force multiplied by time, and force into time is actually what? Is actually area under ft graph, force time graph. So that means I can write impulse is equal to what? Impulse is the area of the force time graph. Force time graph. So that means if you have been given a force time graph, right? So if you just calculate the area of the force time graph, you will get the net impulse. Okay, so suppose I just take the example of the first graph. In the first graph, what will be the area of the force time graph? See, the force is acting in this manner, right? The force is acting for this. This is the force acting for a time t, right? So that means this is the area, right? This is the area. The net area that is enclosed by the force, right? So this is the area enclosed, right? So that means if I calculate this net area, this will be the impulse that is acting on the object. Okay, so suppose the impulse acts on the object in this manner. Force increases first, then decreases first with respect to time. So that means the area enclosed by the force will be how much, right? This, in the force time graph, this will be the area enclosed, right? So that means if I calculate this net area, this will be our impulse imparted to the body. Similarly, for an arbitrary case, right? Suppose the force is varying arbitrary with respect to time, right? So that means if I just can calculate the net area that is in close, that means this area, the net area that is enclosed by the force time graph will be this area, right? So if I just calculate this area, I'll get the net impulse that is imparted on the object. So the conclusion is that whenever you are given a force time graph, you just find the area that is enclosed by the force time graph and you'll get the impulse. Okay, so from here we can also write that impulse, which is the area under the force time graph, and what is impulse from the previous video? The impulse from the impulse momentum theorem, impulse is nothing but change in the momentum. Okay, so if you just remember this, you can solve any problem. So proceeding on to the next example, we have the sketch shows the force acting on an object that varies with time. The mass of that object is 50 kg and initial speed is 0. So that means initially the mass was 50 kg and it was at rest, right? Because its initial velocity was 0. Then what happened? Then an impulse acted on the object, right? Then an impulse acted on the object. Suppose the impulse is acting in this direction. Okay, so that means over here, how can I find the impulse? If I just know the force time graph and find the area enclosed by the force time graph, I can find the impulse, right? So that means over here the force time graph is given, right? So we just have to find the area under the force time graph, right? So that means the area under the force time graph can be divided into 3 parts, right, for calculation. So that this first part, this is the first part, right? This is the triangle, right? What is the height of the triangle? Height of the triangle is how much? 15. I can write the height of the triangle as 15, right? Because it's touching this point. What is the base of the triangle? It's spanning from 0 to 5, right? So that means base will be 5. Similarly, what will be the second area? The second area will be a rectangle like this. I'm just dividing the area to calculate the net area easily, right? So that means the second area will be a rectangle. So this plus a rectangle, right? What is the length of the rectangle? See, the graph is spanning from 5 to 20, right? So that means the length of the rectangle will be how much? The length of the rectangle will be 20 minus of 5, right? So that means from here to here, right? So that means this length is how much? 15. So that means the length of the this rectangle will be how much? Will be 15 meter. What is the height of the rectangle? Height of the rectangle is also 15 meter, right? This side. So that means this is also 15 meter. So this plus I can write the third area will be this, right? This is a rectangle. See, so this will be a rectangle. So what is the length of the rectangle? Sorry, the base of the rectangle is spanning from 20 to 25, right? So that means this will be 5 meter. So this is 5 meter. What is the height? Height will be this, right? Height is how much? 15. Okay, I'm just cancelling out the meter over here. Okay, so you just don't get confused. Okay, so that means I have the numbers for all the rectangles and all the areas. Okay, so that means I can now find the net area. So what will be the net area? So impulse will be the area 1 plus, suppose this is 1, this is 2, and this is 3. So area 1 plus area 2 plus area 3. So impulse will be equal to, how much is area 1? What is the area of a triangle? Half into base into height. What is the base? 5. Height is how much? 15. Plus what is the area of a rectangle? 15 into 15, that is length times of breadth, plus area of the third, that means half into base into height, which is a which is a triangle, half into 5 into 15. So that means I get a net impulse as so this will be how much? 15 times 15 is 225, plus it will be 75. So this means I have a net impulse I, which is equal to how much? 300. So 300, you have to write the unit also. You can write Newton second or kg meter per second, as you like. Okay, so I have treated the body such that it's acting, the impulse is acting towards the east. Okay, so that means over here I will specify east also. Okay, so we also got the impulse. Now we have to find the final speed of the object. Okay, so in order to find this final speed, we'll use impulse I is equal to, we know that impulse I is nothing but delta p, which is the change in the momentum, right? So what is delta p? M times of final velocity minus m times of initial velocity, right? See what is happening over here. Initially the body, right, initially the body was at rest. The body of mass 50 kg was at rest. So this was our initial condition, right? After some time what happened was that on the block of mass how much? 50 kg, this impulse that we calculated started to act for the amount of time that is specified. So after the application of impulse, what will happen? It will get some velocity in this direction, right? In this direction it will get some velocity. Why? Because impulse causes the change in the momentum and it does not impart acceleration, right? So that means over here final case will be the body will move with some velocity in this direction. Suppose this velocity be v1. So that means from here I can write that impulse is equal to delta p, which is m times of final velocity minus m times of initial velocity, right? So that means from here I can write that impulse is equal to, what is mass? Mass is 50 kg, final velocity is v1 minus what is mass 50, initial velocity 0. Why 0? Because it was at rest. So impulse is, what is impulse? Impulse we derived, it was 300, right? It was 300 Newton second towards the east. I'm not writing the unit over here because you'll get confused. 300 towards the east, which will be equal to 50 times of v1. So that means 50 times of v1 is nothing but 300 towards the east. So v1 will be how much? 6 meter per second towards the east. Okay, so whenever you are just solving for impulse, whenever you are a bit in the middle of an equation, don't write the units, you'll get confused. After solving, then write the units. So what is v1? v1 will be 6 meter per second towards the east. Okay, so I hope you got the question. Thank you for watching. We'll be coming with more examples, lots of examples on impulse and force time impulse graphs. And thank you for watching, and do subscribe. Thank you.